Hi everyone, welcome back to my channel. So in this video, we will be solving the problem of Leetcode-204, that is count prime. And also we will be looking at another approach how to solve this problem. So to get a better understanding, let us find the initial approach that every student will be facing, like count prime. Let us move into the question. So the question states, given an integer n, return the number of prime numbers that are strictly less than n. Okay, then input is given n10, the output is 4. How? Because in between 10, 0 to 10, the prime numbers are 2, 3, 5 and 7, right? Because in the range of 10 there are 4 prime numbers, that is 2, 3, 5 and 7. So what is prime number? Like a prime number is a number that is divisible by 1 and itself, 1 and itself. So the range is 2, 3, 5 and 7, that is 4 prime numbers. So the output is 4. Similarly, if n is 0 or n is 1, then there is no prime number, right? Because prime number should divisible by 1 and itself. So output is 0, and for n equal to 1, output is still 0. So the initial approach that every individual will be having, like we have given a range that is n equal to 10. So like where we can write all the range. Okay. First, the initial approach is that every individual will be having, like we will select a particular number and we will check if it is prime or not. Similarly, 3, we will check if it's prime or not. Similarly, for 4, 5 other, like this, we will check. And the solution of this approach is goes like this one. So in the, we have initialized the index and we have set the count. So we have taken prime as 0 initially. Now we will start from 2 till n minus 1 because it should be less than, strictly less than n. And why we have not taken 1? Because prime number is divisible by 1 n itself. 1 n itself. So the iteration starts, count 0, index from 1. That is, I was telling now that for each number we will be checking whether it's prime or not, and for the next number also we will check. Like for each integer we will be checking that whether it's a prime number or not. Like many iterations will be there, n square, yes, right, n square iterations will be there, complexity. So this is the uh, brute force approach given. So if I modular index, that is the index that is first number taken, if it is between the range and it is divisible, then we have incremented the count, and at last we have checked if count is equal to 2. Why 2? Why not 3, 4 or any other integer? Because I have said na, prime number is a number that is divisible by 1 and itself. So for divisibility condition, we have given if I modular index equal to 0, that is divisible by 1 in itself. So it should happen only twice, right? Only twice it will be true. So count will be equal to 2. If count is greater than 2, then it's not a prime number. So that is the approach. Let us run the code. Yes, let us run all the test cases. Okay. Before submitting, let me tell you the constraints. Like 10, 0, n should be in range, and will be in range between 0 to 5 into 10 to the power 6. Okay, let us submit. We will be getting TLE. Yes, exactly what I was saying, because we will be getting TLE because in the constraint it is mentioned that it is, but our complexity is n squared, that is nearly 10 to the power 12. You can relate it like n squared 10 to the power 6 into 2, 10 to the power 12. So how to optimize the solution and get the correct solution? So to get the correct solution, we have came across a very good approach, that is using Sieve of Eratosthenes. That is This is an approach. It's actually very difficult to spell. So you can say for the sake Sieve of Eratosthenes. So what does this approach states? It states that we have given a number, right? So first we will write all the numbers in between this: 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Now, now the game starts. Initially, initially we will mark all the integers as prime. The step one. Okay. Now everyone is prime number. Okay. Now we will start the iteration. Now 2. Now in next elements we will check what are the elements which are multiple of 2, right? Which are divisible by 2, which are a factor of 2. So 3 is not a factor, right? 4 is a factor of 2, so we will directly remove. 5 is not a factor, we will directly remove. 7 is not a factor, 8 is a factor, we will directly remove. 9 is not a factor, 10 is a factor, we will directly remove. Okay, okay. So 2 is the prime number. 2 we will store it as in the form of count. Now coming back to 3, what we will do, same multiples of 3, common factors of 3. For that particular number, we will check the next numbers which are multiple of that initial current number. So 5 is not a multiple, 4 is already gone, 6 is already gone, 7 is not a multiple, 8 is already gone, 9 is a multiple, we will remove simply. Now coming to 4, 4 is not available because it has been already removed. Now coming to the 5, multiples of 5, there is no multiples of 5 available, we directly store it. 6 is already removed. Now coming back to 7, multiples are not available directly. So the count is 4, right? So that's how we will calculate count prime using Sieve of Eratosthenes approach. Let me give another example for better clarity. Suppose the number is 20. We will write all the range. Now we will start the iteration. First, initially we will mark all as first step, same, mark all integers as prime. Okay. First, we will take 2 and we will check all the multiples of 2. 4 is multiple, remove. 6 is multiple, remove. 8 is multiple, remove. 10, like this, 12, which are in the table of 2, right? In the table of 2. Now coming to 3, remove all the numbers which are coming in the table of 3. Now coming to 5, remove all the multiples of 5. Done. Now coming to 7, remove all the multiples of 7. Now coming to 11, remove all the multiples is already removed. Now coming to 13, remove all. Now coming to 17. Now coming to 19. So what is the count? 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the answer. So you got it? First we will consider all the integers as prime. Then we will select particular integer and we will check the corresponding integers are the table of that are in the table of that number, we will directly remove that other integers, and like that we will proceed further. So the optimized code will go like, initially we will be taking a vector of bool type, and I've said now in the first step we will mark all as prime, so here we are marking all as true. Let us run. So let us submit. So it's working fine. So let me explain the solution, what happened. So we will starting from 2 and we will check if ans of I is true. Initially we have set all the integers in the range true. Now we will increment count, and after that selecting that particular number in the first for loop, outer for loop, we will iterate. If others are in the table of that outer for loop number, we will directly mark it as false, and similarly the iteration continues and we will return the count. So yeah, that was all about in this video. If you really like this video, please do like, subscribe my channel, and I will be coming up with more content like this. Thank you.